So, to begin, how do tornadoes tend to form? Okay, you guys keep mentioning how cold air and hot air mix, and that's not totally wrong. It's just not the whole story. But it is partly right. Warm, empty air. What does MT stand for? Yes? Do you remember? Maritime tropical. So it comes from where? It comes from the ocean. Is it from the warmer equator ocean or the colder polar oceans? The warm ocean from the equator. So warm, empty air meets a CP air mass. Continental polar. So that cold air from the poles. Okay? Okay. Now if this happens, you'll get rain, you'll get lots of interesting things. But more things have to happen to get a tornado, right? And I'm doing my very, very best to keep these things halfway simple. Here's the picture I gave you. Now in your notes, you'll notice something. This column that's going up, this updraft, is it perfectly straight up? Okay, when you're cooking on the stove, that steam that's going up, that's going straight up, isn't it? Unless what's happening then? If it's not going straight up, what must be happening? What's going to have to be coming from this direction? No. Good guess. Basically wind. What you need to have, you need to have a strong wind towards the top, but a weaker wind down here at the bottom. Let's call it a mild wind. So a strong wind up at the top is kind of pushing it over. That's the second thing that you need for a tornado to form. So secondly, the higher level winds are faster than the lower winds, is the second little bit of notes. Okay? Make sure you draw a large arrow and a small arrow to show that. Because if you don't have these winds right, what ends up happening is the air comes up, it condenses, it starts making rain, and that rain falls right back down upon the air that's coming back up. And that basically messes the whole thing up. You don't get a strong updraft that's continuous. So you'll end up with rain. You'll get lots of rain, but you won't necessarily get a tornado. Okay? Now, next. If we have a strong wind right here, and we have a mild wind down below it, in the middle here, something weird is going to happen. You're not going to have just medium wind in the middle. Something else is going to happen. Does anyone know? It's going to make a spiral, actually. It's going to circle around. It's going to make kind of a loop. That top wind is going to loop the top part over, and the slower wind is going to drag the bottom part around. And so you're going to end up with a loop right here. And that tumbling loop ends up doing something special too. The rotating air gets caught in the updraft. So, you guys have seen these before. Right now, you see the bubbles, right? I know you're busy writing, but you see bubbles, right? Think of those bubbles like the updraft. Is there any order to the updraft right now? It's kind of random, you know, and it's still getting up there, but it could be better. If you add some rotation to that updraft, the updraft absolutely uses it. And that rotation gives it order, it gives it structure, it gives it like some strength, basically. And what was a weak updraft is now what? A whole lot stronger. So the rotating air gets caught in the updraft, and that's not just a minor detail. That rotating air is what intensifies the updraft. We don't have a tornado yet. All we have is an updraft that's swirling. Does anyone know what that's called? A cloud that's swirling?
Funnel cloud, wall cloud.
Funnel cloud, yeah. Good job. So basically, right now we have a funnel cloud. Okay? So we have an updraft. It pulled some rotating air in there. And that rotation makes the updraft gain a lot of structure, go a lot faster, everything else. The last thing that has to happen, you'll notice in this picture, there's something like a rotating, a rear flank downdraft. And what they think happens, the best idea that we have, like no one's totally sure, is that some sort of downdraft ends up pulling that rotation down to Earth, or basically pushing that rotation energy down to Earth, and that's what looks like a tornado. So you need some sort of downward motion back here. So you can have a funnel cloud, but if nothing ever moves here, it'll just stay a funnel cloud. You can have a funnel cloud, and if something, some convection, some air mass moves down at all, it can end up pushing that funnel all the way down to the Earth. And so then in your notes, finish up by saying, a rear flank pushes the rotating column down. A rear flank. So,
tornadoes occur on every continent except Antarctica, but more form over the central United States than anywhere else in a zone called Tornado Alley. That's because conditions in the alley are ideal for creating tornadoes. Warm, humid air low to the ground moves north from the Gulf of Mexico and collides with cool, dry air high above the ground rolling in from the Rocky Mountains. The collision of air masses creates a supercell, a massive thunderstorm that has a strong rotating updraft of air. Scientists aren't exactly sure what happens next, but the leading idea goes like this. The difference in speed between the faster high winds and the slower low winds causes the air in between to rotate around a heart.
Did we cover this? We have faster high winds, slower low winds. We covered that. So this faster high winds pushes it forward. The slower bottom winds kind of pull it around. You get that rotation. What's the second step? The rotation what? The rotation gets caught in the updraft. So that updraft is pulling air up. And that rotational energy really likes being focused. So we'll see that happen right now.
Horizontal axis. If one end of the rolling air gets caught in the updraft, it's bent upward and forms a funnel cloud. Its spin gets tighter and faster, and the cloud gets longer. Rain or hail from the thunderstorm can then push down on the tail of the funnel cloud till it reaches the ground, forming a tornado. The top wind speed of most tornadoes is usually under 110 miles an hour, and most are on the ground for less than 10 minutes. However, extreme tornadoes are truly extreme. The longest tornado path was cut by the Tri-State tornado on March 18, 1925. It tore up property for 219 miles, was on the ground for well over 3 hours, and killed 747 people. Which is why I'll be hanging out here in Antarctica with the penguins until tornado season is over. For Scientific American's Instant Egghead, I'm Mark Fischetti.
I don't expect you to memorize absolutely everything here, but you should know that there is warmer, moister air coming in. You should know that the higher level winds are faster, and that we have some sort of rotating air along the way. So make sure that you don't have to have it memorized, but know that there are those three things for sure. Now, towards the bottom, a tornado watch. What's worse, a tornado watch or a tornado warning?
Tornado watch.
A tornado warning is worse. So, a watch means when conditions are favorable. Basically, when you have all the ingredients, but they haven't come together yet. A tornado warning, on the other hand, we've already had a tornado watch where those pieces are there, but a tornado warning is when they look like they're coming together in a bad way. And the shortest way we could describe this is that a severe weather is imminent. Imminent meaning on the way or it's coming, would be another way of saying it. Okay, it's not a guarantee that you're going to have bad weather, but it's a sign that bad weather is highly likely. Okay? So, the F scale. Most tornadoes, there are probably thousands of tornadoes in Minnesota that are F0. And most of them don't even get reported because they're not that huge of a deal. This will probably take shingles off your house. Maybe it'll crack your siding. Maybe it'll break a window. Maybe though, maybe not. Maybe it'll take some branches down. And F1 is a little worse. That's going to break some windows. That's going to tear some roofs off. It's no good. Everything after F1 is pretty severe, pretty serious. Okay, so I'll just let you go at it. Now, this chart that I found here ends F5 at 318 and tells you that F6 is 319 to 379. I don't know why they said to 379. Is after 379 and F7? I don't know. Other charts that I found only go to F5 and say 261 plus. So there's a little bit of conflict there. I'd be interested to see if there are any F6 per year. There's probably one or two F5s per year. Okay. Tornado Alley is the part of the U.S. that sees the most tornadoes of anywhere in the world. Basically, Tornado Alley has more tornadoes than everywhere else in the world combined. So the United States is pretty unique in how many tornadoes we have. They're pretty rare everywhere else in the world. Okay? And it took me a while to look, but here's the best map I could find of Tornado Alley. Right over Oklahoma. It's like a bullseye. The whole state. And basically from Texas all the way up to southern Minnesota, shaded nice and dark, that's primarily Tornado Alley. Some maps you'll see will show us being in Tornado Alley, and that's not that they're wrong, it's just that they're including a larger area. We do get a fair number of tornadoes here. Okay, it's not as bad as Oklahoma, but it is pretty severe, right? So I won't expect you to memorize anything except just know Tornado Alley goes from Texas up to the southern border of Minnesota, primarily, over into Iowa. That is all.